Section 3.3, Rules of Differentiation. In this next video and the next couple of videos, we're going to learn about all the different rules for derivatives. In previous lessons, we've learned about how to take a derivative using the definition of a derivative. In these next videos, we're going to learn about how to use different properties to take derivatives much faster. Similar to other math properties, we have rules that allow us to take shortcuts to solving problems. So in these next couple of rules, all the functions f of x, g of x, and h of x are all differentiable functions, and n and c are going to be constants. And we'll see where n and c are going to come in a minute. So rule number 1 is the derivative of a constant. This is where f of x is equal to c, where c exists in R. So c represents like 5, 6, 18, it doesn't matter. So we have like f of x is equal to 5, which on a graph looks something like that. So we know that the derivative of that is equal to 0. So the derivative of any constant is just 0. And the reason for that, so if we have an example, f of x is equal to 3, then f prime of x is equal to 0. And that's because the slope of this line right here is 0. The next rule is we call the power rule. And the way this works is if we have a function raised to a power, all we have to do is take this power here and bring it down to the front and then subtract 1. So in example, we have f of x is equal to x cubed. So in order to take the derivative, if I want to find f prime of x, all I have to do is take this 3 and bring it down to the front and then subtract 1. So I'm going to get, this is 3 times 1, which is 3, x, and 3 minus 1 is 2. So the derivative of x cubed is 3x squared. So let's try another one. F of x equals 5x. So when I take the derivative of that, I get f prime of x is equal to the derivative of 5x. So if there's no power written here, we write this as a 1. So the derivative is equal to 5. And then this 1 comes down to the front, and you minus 1. So you get 5 times 1, x, 1 minus 1. So then the derivative, 5 times 1 is 5, and this becomes x to the 0. And we know that anything to the 0 power then is just 1. So you get 5 times 1 is 5. So from this, we get a nice little theorem, which says if f of x is equal to a times x, then f prime of x is just equal to a. And that's because a times x would be a line, and so we're just looking for slope. Rule number 3 is called the constant multiple rule. This says that if you have a constant times a function, you can take the derivative and then multiply by that constant. So let's do an example of that. We have f of x is equal to 2 times x cubed. So then f prime of x, we just ignore the constant, it stays outside, and we just focus on the derivative of x cubed. So we have f prime of x is equal to 2 times 3x squared, which becomes 6x squared. So let's try another one. This is f of x is equal to 4x to the 6th plus 2x to the 10th. And so if we take the derivative, we get f prime of x is equal to 4 times 6x to the 5th, because 6 minus 1 is 5, plus 2 times 10x to the 9th. And then we just have to simplify that a little bit. You get 24x to the 5th plus 20x to the 9th. So if you notice, the exponent and the coefficient multiply to give us our final numbers. And then to get the number before that, or the number in the exponent, we subtract 1 from the powers. The next one we're going to learn is called the sum and difference rule. And this is said that the derivative of a sum is the sum of the derivatives. So the derivative can quote-unquote distribute to the two functions. And I'll show you what I mean by that. And we kind of saw that in the last example as well. So if we have f of x is equal to 2x plus x squared, if we take the derivative of that, we get that the derivative of 2x is just 2 plus 2x. So again, it's really just using the power rule. However, now I'm going to rewrite it a different way. I'm going to write y is equal to 2x plus x squared. Now notice it's not f of x anymore. So the notation for that, for the derivative of both sides with respect to x, is we write d dx on both sides. This means that we're taking the derivative with respect to x. So then we're going to get dy dx is equal to x plus 2x, which if you notice is the same thing we get either way. So it's just a different form of notation, but you must be able to recognize both. So example 1, determine dp dt if p is equal to t cubed plus 6t squared minus 5/3 t plus 16. And then part B says dp dt when t is equal to 0. So we read this as the derivative when t is equal to 0. So let's start by doing part A. So we have p is equal to t cubed plus 6t squared minus 5/3 t plus 16. And we want to take the derivative with respect to t on both sides. So we get that this is dp dt is equal to, and the derivative of t cubed is 3t squared plus 2 times 6 is 12t, and you subtract 1 from 2 and get 1, minus, and then the derivative of this is just 5/3, and the derivative of a constant is 0. So that's my derivative. And now part B wants dp dt when t is equal to 0. And so what we're trying to do now is find the slope of the tangent line when x equals 0 or t equals 0. So all we have to do is just plug in 0. So you get 3, 0 squared plus 12 times 0 minus 5/3. And so you get this is negative 5/3. Now I want you guys to try to determine dy dx for y is equal to x to the 4th divided by 4 plus 2x minus 5. And then I want you to determine dy dx when x equals 0. All right, let's give it a try. So for part A, we get dy dx is equal to 4 divided by 4x cubed plus 2. And so we get dy dx is equal to x cubed plus 2. And now for part B, we need to do dy dx when x is equal to 2. So we get 2 cubed plus 2, which is equal to 8 plus 2, which is 10.